Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Cikgu, suara tak dengar cikgu. Mic tak buka cikgu.
Sorry. Okay. Assalamualaikum dan salam sejahtera. Hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasih sekalian. Selamat datang ke Pusat Tuisyen AYU, usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Ingat, hashtag bermula percuma, selamanya percuma. Untuk mendapatkan keberkatan kelas kita pada petang ini, bagi yang beragama Islam, marilah kita sama-sama mulakan kelas dengan membaca kitab Al-Fatihah, dan kepada yang bukan Islam bertakafus sejenak. Al-Fatihah. Amin, amin, amin ya rabbal alamin. Apa khabar para pelajar yang cikgu kasih semua? Harap semuanya berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada petang ini. Walaupun negara masih dalam fasa lockdown serta pelajar pun masih lagi dalam cuti persekolahan, namun jangan lupa isikan masa anda dengan tuition online percuma ini. Cikgu percaya pelajar-pelajar dah tak sabar untuk mengikuti kelas perayu khusus untuk STPM dan matrikulasi. Sebelum itu, cikgu perkenalkan diri dahulu. Nama cikgu, Cikgu Suryati binti Muhammad ataupun Cikgu Su dari Pusat Tingkatan 6 SMK Seri Serdang, Selangor selaku moderator pada petang ini. Okey, bersama cikgu di studio pada petang ini juga Teacher Im dari Kolej Tingkatan 6 Tapah selaku host, Cikgu Hafsah Ayu binti Muhammad Arifin dari SMK Sultan Sulaiman Kuala Terengganu sebagai pemerhati. Dan presenter kita pada hari ini iaitu Madam Rosmaya binti Mokhtar dari SMJK Yuhua Kajian Selangor. Pada petang ini kita bersiaran secara langsung dari channel Madam Rosmaya. Sesiapa yang belum subscribe beliau, silalah tekan butang subscribe sebagai tanda sokongan kepada Madam Rosmaya. Okay, tajuk yang akan disampaikan oleh Madam Rosmaya pada petang ini, Force on a Current Carrying Conductor. Pelajar dan para penonton lain dialu-alukan untuk mempelajari topik ini. Kelas ini akan berlangsung lebih kurang 1 jam. Sebelum kita teruskan kelas kita, suka cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar-pelajar yang cemerlang dan marilah kita tunjukkan disiplin yang terbaik. Sila fokus pada isi pelajaran yang akan disampaikan oleh Madam Rosmaya dan menggunakan ruang chat untuk menjawab soalan atau jika ada soalan yang hendak diajukan. Okey, pada akhir siaran ini, link ECJ akan diberikan bersama kod akses. Pastikan anda menggunakan email e-didik dan satu perkara baru, ada mata ganjaran kredit kerana mengikuti kelas tuition AYU. Anda boleh menebus dengan hadiah istimewa. Anda perlu memohon ID e-didik junior terlebih dahulu sebelum mengisi borang klaim kredit. Link untuk memohon ID e-didik junior diberi semasa kelas berjalan nanti. Anda semua boleh mengisi borang klaim kredit apabila diberi link di akhir kelas. Okey, kod untuk klaim kredit ini ada 4 digit ya, ada 4 digit. Pastikan anda mencatat dalam kertas. Untuk meningkatkan integriti, diminta jangan share kod kelas yang diberikan. Okey, tibalah masa untuk cikgu bagikan nombor kod yang pertama. Okey, kod yang pertama ialah 8. Okey, ini adalah kod yang pertama. Tanpa membuang masa lagi, cikgu serahkan kelas kita kepada Madam Rosmaya. Dipersilakan, Madam.
Okay, hi everyone. Okay, I am Madam Rosmaya. Welcome to my YouTube channel and what we're going to learn for today. So before we start our lesson today, okay, I would like to introduce myself. Okay, my full name is Rosmaya binti Mohtar. Okay, I am a teacher, okay, Form 6 teacher at SMJKU Hua Kajang, Selangor. Okay, my teaching experience is 28 years. Okay, I've been teaching since 1994 until now. Okay, that's all for me. So before we start our lesson today, okay, I would like to introduce our collaborative with other subject in PRAYU. PRAYU like biology, we have here biology, mathematics, chemistry, and also the accounting and economy. So you can get the most of the video, okay, from their playlist. Okay, the first one you can get from mathematics. Okay, lead by teacher Im. Okay, we have here teacher In with us here. Okay, and then we have also this is our physics playlist at the www.academyyoutuber.com. You can get from there. Okay, and we also leading by me, okay, and then the biology PRAYU led by Cikgu Faiza. Okay, and then we also have chemistry, okay, PRAYU lead by Cikgu Shahnun. Okay, Cikgu Shahnun. Okay, another one, we also have peraccounting dan ekonomi PRAYU, okay, in our team. Lead by Madam Fizi. Okay, so our lesson for today, our discussion for today is on the main topic. Our main topic is magnetic fields. Okay, so the subtopic, so in this topic is force on a current carrying conductor. So what is our objective for today's lesson? Okay, our objective is by the end of this lesson, you all would be able to explain the existence of magnetic field on a straight current carrying conductor placed in a uniform magnetic field. And second, you can derive and use the equation F equals to BIL sine theta. So F is force, B is magnetic field strength, I is current, and L is the length, length of the conductor we use here. Okay. So we will discuss how we get this equation, okay, the formula. Okay. Okay, first, why does a current carrying conductor experience a force in the magnetic field? Like the animation shown here, okay, you can see that the conductor used here is rotating, okay. So the current carrying conductor means that the wire here, okay, the conductor here has current flow through it, okay, and then under the battery here, the cell here supply the current, and we have a magnet. We have magnet. Okay, I make it bigger here just now. Okay, we have magnet here. So what happened to the wire here? You can see it is rotating. So it is because of the force, in the presence of the force. So why this happen? Okay, so why does a current carrying conductor experience a force in the magnetic field? So we can explain this in two ways. Okay. Okay. The first one, we have learned this before in the previous chapter. Okay, and also in Form 4, Form 5, you have learned this. Okay, so a moving charge experience a force in the magnetic field. So refer to the animation here. The blue dot here means the charge. When the charge moving first in a straight line, and when it enters the magnetic field, so what happened to the charge here? You can see that the charge move in a circular motion. Okay, move in a circular motion. So the force is towards the center of this circle, right? The circular motion. So the charge here will experience a force in the magnetic field. So now relate to what we are going to discuss today, a current in the carrying conductor. So the conductor has a current flow through it. So what is current actually? current is also a flow of charge. From the Form 4, Form 5 you've learned, I is dq by dt, right? So the rate of flow of charge. So the charge involved is the electron. Okay, current actually in the current is a flow of electron, right? So if the wire carrying a current and it is also a flow of charge, so therefore the current should also experience a force. So it's logic, right? Okay, this is what we can explain why the current carrying conductor experience a force, okay, in a magnetic field. Okay, another way we can describe this, okay, why a current carrying conductor experience a force in the magnetic field. Okay, so when have you ever done this experiment before, right? When you are in Form 4, Form 5, okay, if you put a compass in the through a wire here, so you will see that when the current flow through the wire here, and you can see the movement of the compass. Okay, what does this mean? Okay, what does this mean? This means that there is a magnetic field around the wire, right? There is a magnetic field around the wire. So the current carrying conductor has magnetic field around it. Okay, now what if we put together a magnetic field from let's say a permanent magnet. So these two magnetic field from the current carrying conductor and also magnetic field from the permanent magnet. Okay, so they will interact with each other. Okay, they will interact with each other. So that is why the conductor experience a force. Okay, so I repeat in a proper sentence here made for you. So when a current carrying conductor is placed in the magnetic field, so the wire experience a force due to the interaction between the magnetic field, okay, from the wire itself, okay, the current carrying conductor, and the magnetic field produced by the permanent magnet. Okay, means that they both interact with each other, so they will experience a force. The wire itself experience a force. Okay, so there are two ways in describing why a current carrying conductor experience a force in a magnetic field. Okay, so if you have any questions, you can ask in the chat box there. Okay, so next, we go to the next. We are going to also do some revision in Form 4, Form 5 because we need this Fleming's left-hand rule, if you can remember. Okay, you have learned in Form 4, Form 5, so we are going to use this again. Okay, when a conductor carrying a current, okay, is placed in the magnetic field, okay, the conductor experiences a magnetic force. Okay, this is what we have discussed. Why we have discussed just now in the previous slide. Okay, so the direction of the force, okay, can be determined, okay, by using Fleming's left-hand rule. Okay, so the direction of this force always right angles to the plane containing both the conductor and the magnetic field. Okay, and we can use Fleming's left-hand rule. Remember to use left-hand rule. Okay, so the Fleming's here names after one of the scientists. Here, look at the slide I've shown here. Okay, this is Sir John Ambrose Fleming. So this come from from him. Okay, so the thumb shows the direction of the force, okay, and the magnetic field by the forefinger, okay, and the middle finger shows the direction of the current. Okay. Okay, next we are going to derive the equation of F of this formula. F equals to BIL sine theta. So how we get this equation? Okay, in Form 4, Form 5, you just know the Fleming's left-hand rule. So where it comes from actually? Okay, it comes from this equation, F equals to BIL sine theta. So today, today's discussion, we are going to derive this equation. Okay, so we are going to use the formula that we have learned before. In the previous chapter, we've learned from I equals to NEVA. Can you remember or not this equation? Where the current is equals to the N number of charge density. okay, number of charge divided by volume, small letter n stands for the number of charge density. So E is the charge of electron equals to 1.6 times 10 to the negative 19 coulomb, okay, the charge for one electron, and the V is the drift velocity, and A is the cross-sectional of a wire. So imagine we have a wire here, so we make the part of the wire here larger, so you can see there are numbers of electron here flow through the wire here, okay. So we are going to use the N here, N equals to I per EVA, okay. Next, we are going to use the previous equation also. We have formed F equals to QVB. Okay, this is for where the charge, when it's flow through the magnetic field, so it will experience this force, F equals to QVB. Okay, so in this case, it's electron that flow in the wire here. So therefore, the charge here we can substitute into as a E value. Okay, and lastly, okay, N here is a number of charge per volume. Okay. In other words, this is number of charge density, okay, number of free electrons per unit volume. So we are going to use all these three equations, combine all the three equations, and to get the F equals to BIL sine theta. Okay, so let's start how to use it. So actually not just for one electron, we have many electrons here. So the total of force will be N times F, okay, N times F. N is the number of free electrons. Okay, and then the F here, EVB, okay, force of one electron, because in the presence of magnetic field, okay, the electron flow in the presence of magnetic field. So we can substitute into the equation here, N times EVB. Okay, so next, so N, this N is a number of charge. So therefore, N equals to small letter n here V, number of charge density times the volume. So we substitute into here. Okay, so next, the volume here also can be expand. Okay, so volume, imagine the wire here is in the shape of a cylinder. In the shape of cylinder, we assume that the shape of the wire is a cylinder. So you can substitute the volume as a cross-sectional area of the wire times the length of the wire. So A times L. A is a cross-sectional area of the wire. Okay, next, another one, this N. The number of charge density here, N equals to I per EVA. Also, we substitute into here. Okay, and finally, what we get? We cancel out all the same variables. The physical quantity here is we have A, we can cancel out A, and we can cancel out B, and also E, the charge of electron. Okay, so finally we get BIL. There we get already part of the force, F equals to BIL. And what is theta actually? Okay, so the theta actually the angles between between I and B, I and B. Okay, between the conductor actually, between the conductor and the B. Okay, remember that we use Fleming's left-hand rule. So the Fleming's left-hand rules means that all the F, B, I and L, B, I, L and F must perpendicular to each other. Okay, so let's try. So this is the thumb. I repeat, the thumb.
Okay, sorry, Madam Rosmaya.
Yeah.
Okay, before we continue our lesson, so boleh tak saya bagi kod yang kedua?
Okay, can.
Okay, so kod yang kedua adalah kosong. Kod kedua adalah kosong. Okay, so Madam, boleh sambung?
Okay, so we continue, okay, with our discussion today. So to recall what we've learned from Form 5, again here, the thumb shows the direction of force, and the forefinger shows direction of B, and the middle finger shows direction of I. Okay, direction of I. Okay, so general expression, okay, F, B, and I must perpendicular to each other. Okay, So this one given by the cross product. Okay, in the form of cross product, general expression we can write as I bracket L cross B. Okay, when we, okay, L is the length of the conductor, okay, in the direction of current. And then F, okay, is given of cross product here, L cross B. And then for the direction, okay, direction, we use Fleming's left hand rule. Okay, so to get the magnitude, okay, make sure all of them are perpendicular to each other. So that's why we resolve the component, either one you can resolve the component of B or you can resolve the component of L stroke I, okay, so that you get sine theta, L sine theta, okay. So make sure when you want to find the magnitude of F, okay, all of this F, B, I, all of this physical quantity, force, magnetic field and I perpendicular to each other, must be perpendicular to each other. So that's why we have sine theta. You can resolve the component of B becomes B sine theta, or you resolve the component of L becomes L sine theta, because I is in the direction, L is in the direction of I, okay. So that's why the sine theta comes from. Okay, for more understanding, we will do example later. How we can resolve the component here. How we get sine theta, L sine theta or B sine theta. As long as the angle theta is in between B and I, B and I. Okay, the angle here, B and I. Because the final result is we are going to determine the direction F. That's why the angle is in between B and I. So I repeat again here, this is force, forefinger is magnetic field, and the middle finger is current, current stroke L, okay. So current in the direction of L. Okay, this is the angle theta. Okay. In the exam, especially when it comes to the essay question, usually they will ask the definition question. So one of the definition question is magnetic flux density B. Magnetic flux density B. So in the previous lesson, we have derived the definition of the magnetic flux density B, okay, using this formula. Okay, this is previous lesson where from F equals to QV cross B. Okay, in the magnitude form, after resolve the component B and V, either one, if they are not in perpendicular to each other. So we get F equals to QVB sine theta. Okay, so the B is F per QV sine theta. So we can derive the magnetic flux B here, magnetic flux density B, or sometimes if you refer to different book, it may write it may say as magnetic flux, magnetic field strength. Okay, B is also magnetic field strength, or sometimes in some book it states as magnetic flux density. So both is the same meaning. Both have the same meaning. I repeat, magnetic field strength or magnetic flux density. Okay, both is the same meaning. Okay, so we can give definition for B. Okay, as this one, if sine theta is 90 degrees perpendicular to each other, so we can write as B is the force on a charge of 1 coulomb moving with velocity of 1 meter per second at right angles to the magnetic field. Okay, by referring to the formula here, okay, it might help you to define it like this. Okay, so B is the force here, the force on a charge, Q here, on a charge of 1 coulomb. Moving with a velocity of 1 meter per second, here the V here, 1 meter per second, at a right angle, okay, to the magnetic field. Okay, so another way, this is what we have derived, we have discussed before in the previous lesson. So another definition for magnetic flux density, we can use using today's formula. We've derived this now. Okay, so what is the formula we derived this now? Okay, we derive this now, F equals to BIL sine theta. Okay, right? BIL sine theta. So when we arrange this equation, so we get B equals to F per IL sine theta. Okay, so if they are perpendicular to each other, so we get B equals to F per IL. So from here also, we can give definition for B using this formula, So what can be said? What can be said? So we say that, okay, we define that B is the force on a conductor of unit length L carrying a current of 1 ampere at right angles to the magnetic field. Okay, this is another definition you can give. Either one you choose, especially in the essay question when they ask you to define the magnetic flux density or magnetic field strength. Okay, so I repeat, look at the formula here. It can help you to define in a proper sentence. So B equals to F per IL. So B is the force, the force on a conductor of unit length L, here the L, okay, carrying a current of 1 ampere. Here we have current here, okay, 1 ampere, and at right angles to the magnetic field. Okay, so memorize this definition. Either one you can choose. Okay, so next, refer to the one problems given here. We have a wire here. Okay, a wire here. So look at the wire is fixed at 2 points. One end, this is another end, so it's fixed. So what happened of the wire when the current flow through it? Okay, so what happened? You can see here. So the wire will move to one side. Depends on the direction of the current. Okay, depends on the direction of the current. So the cross here, you see the blue cross that drawn here. So this means the direction of the magnetic field, B, magnetic field strength or magnetic flux density is into the wire. Is into the screen. Into the screen. The cross here. So you can imagine this as the refer to the diagram in this side. I show here. So you can imagine north to south. This is in reality. In reality, there is a magnet here. But when we draw, okay, we seldom put the diagram, the magnet here. Okay, we seldom put. So we represent it as the cross here. Cross means the direction of the magnetic field is from north to south into the screen. So into the screen shown here. Okay. So how to know the direction of the movement of the wire? So you can use Fleming's left-hand rule. Remember to use Fleming's left-hand rule. So before you get the force, so you move your middle finger and forefinger in the given direction of B and I. Okay, so the middle finger. Okay, either you can start with I first, B, finally F, because we are going to determine F, right? So I first or B, or you can determine B first, I first. Move your hand. Okay, so now look, refer to here. If you refer to the middle finger, so the current points up. Okay, the current direction is upward, and then the B is cross here, means into the screen. So you position your hand. You can do right now, even though I cannot see you. You can use your hand. Okay, and finally, refer to the thumb. Show direction to the this side. So in your, I cannot see your screen where it is, but for me, I'm seeing is it moved to the right, to the left. Sorry, to the left. Yeah, to the left. Okay, so now the next slide, if we opposite the direction, make the direction of current opposite that this way, downward. So this is the position of your hand. Okay, so the middle finger downward to show the current. Okay, then what else? B. B first. Then finally F, because you are going to determine F. So make sure all these three fingers perpendicular to each other. So actually you've learned this in Form 4, Form 5. So just repeat. Okay, so finally the current move this way. That's why you can see the wire here. Okay, curve to the right, and another one curve to the left. This one left, this one curve to the right. It curved because these two ends, top and bottom, is fixed. It's a fixed point. That's why it curved. Okay, so we go to the next slide. Okay, so
sorry, Madam.
Yeah.
Sorry, Madam Rosmaya. Okay, saya rasa lebih elok kita berehat sekejap untuk memberi laluan kepada iklan. Sementara itu, bolehlah memberi ruang untuk murid kita refresh apa yang dipelajari pada hari ini. Okay, kita sambung selepas iklan ya.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.
Okey, bertemu kembali. Sebelum kita meneruskan kelas kita, jangan lupa ya untuk menunjukkan tanda sokongan kita kepada Madam Rosmaya. Jom kita like, share dan tekan butang subscribe dengan tekan butang loceng channel Madam Rosmaya. Okay, so Madam boleh sambung ya.
Okay, thank you Cikgu Su. Okay, so to test your understanding, what we have discussed before, so it's time to do question. Okay. Actually, I've posted this question already in the description below my channel. Okay, in the description part, you can get from there actually. So next time you must always alert with what given in the description. So if got question, you can check that question first. Okay, the first question. Okay, diagram shows we read first the question. Diagram shows a current carrying conductor in the magnetic field. So this is XY, the current carrying conductor. So in the magnetic field from the permanent magnet here, check direction there, north, south. So we are going to determine what is the direction of the force that acts on the conductor. Okay, this one very easy, just form 4, form 5 actually. So because we need this in our semester 2 physics, physics Prayu. So where do you think the direction is? Either A, B, C, or D? So anyone can write there in the check box there. Okay. Okay, anyone can answer or not? Where the direction? I give you a clue using Fleming's left-hand rule.
Okay, Madam Rosmaya, cekak answer A.
A, the answer. Okay, so you must know the direction, your Fleming's left-hand rule. Where is B? Where is I? And where is the other one is what? B, I, and F. Finally is the F. Okay, so the answer is A. Okay, good. Okay. Correct, Okay, we start with the easy question, but it's okay. How you use your Fleming's left-hand rule. Okay, make sure the direction of the magnet from north to south. Okay, the thumb here, north to south. Okay. So you can, if you still cannot get the idea, actually you can convert the diagram to the 2-dimension diagram. It's easier actually, for those who cannot get lah. So if you cannot get, you can convert it to the 2-dimension diagram. This is 3-dimension. Okay, if you convert it to 2-dimension diagram, so this is north, this is south, you can clearly see the direction of B, north to south this way. Okay, and then from terminal positive to terminal negative, refer to the cell here, sorry. Okay, this is terminal negative. So along XY here, the direction of current is Y to X. Okay, Y to X. So by converting it to the 2-dimension diagram, so that means it's a cross into the screen. Okay, at this point. Okay, this is where we are going to determine the direction of force is. So at this point, the direction of the current is into the screen when you convert it in the 2-dimension diagram. Okay, 2D diagram. And finally, make sure all your fingers, these 3 fingers, perpendicular to each other. And finally, the force is downward. So it's correct. The answer is A. Okay, very good. Who answered just now? I forgot already. Congratulations. Okay. Okay, we try next one. Okay, so what is the magnetic force, okay, exerted on a 3.50 meter length of wire carrying a current of 1.20 ampere perpendicular to a magnetic field of 0.890 Tesla. So the unit for magnetic field is Tesla, T-E-S-L-A. Okay, named after one of the scientists, Tesla. So 0.890 Tesla. So this time diagram not given. Sometimes diagram not given. So how can you remember or not the formula? We are going to use the formula just now. Okay, so I give you times to calculate it using the formula given. If you okay, can you remember the formula just now? Okay, anyone? Or do I need to give the formula? If you can remember the formula, you can on the chat form can answer yes. Okay, if you cannot remember, okay, I can help you. Or anyone can help to put there also the formula. Remember in the SEM 2, in the STPM, okay, exam, we are not given in the exam paper, you are not given formula. So you must memorize all the formula. Okay, you must memorize all the formula. Not like Form 4, Form 5, physics, you are given formula. But in Form 6, STPM, I don't know matriculation, but in Form 6, you are not given formula. So you must memorize the formula.
Okay, ada student tanya, Madam Rosmaya, cengkakit F equal to BIL, correct or not? Okay,
Yes,
so
correct.
missing sin theta.
BIL sin theta. Okay. Okay, so anyone got answer? 3.74 Newton. Okay. So, very good. Okay, it's correct. 3.74 Newton. Okay. So must memorize this formula. So the next question is just to test your memory. Whether you remember or not, the formula or not. So F equals to BIL sin theta. So the sin theta means theta is 90 degrees because stated here perpendicular. Okay, perpendicular. What does this mean, perpendicular? So theta is equals to 90 degrees. Okay, so now to substitute the values of B, I, and L. The angle theta is 90 degrees. Sin 90 degrees is 1, right? You've learned this in maths, at maths. So physics needs maths a lot. So substitute the B, I, and L into the equation and you get 3.74 Newton. Okay, very good. Okay, next, go to the harder question. Okay. Okay, so now let's make the angle at different, not perpendicular to each other. So what the answer? Let's read the question first. Okay, a metal rod carrying a 2 ampere current has a length L equals to 0.010 meter in a magnetic field at an angle 30 degrees as shown here. Okay, so the magnetic field is uniform. Okay, shown here. How you know uniform? Because the distance between the arrow here of the B to represent B is the same. So that's why you know it's uniform. Okay, N has a value of 10 Tesla. Okay, the value of B is 10 Tesla. So find the magnitude of the magnetic force acting on the rod. So use calculate now. What is the magnitude of the magnetic force? Can you remember already the formula just now? Okay. Someone written in the chat box.
Okay. Okay, Madam Rosmaya.
Yeah.
Okay, sementara kita tunggu jawapan daripada student, kita bagi kod yang ketiga, boleh?
Okay.
Okay, ini adalah kod yang ketiga, nombor 3. Okay, nombor 3. Okay, student, let's try answer the question.
Okay, so I
Okay,
write
dah ada
down the
student answer.
formula.
Gao
Okay.
Min Chai, 1.00 Newton.
1.00 Newton. Okay, so let's check the answer. Correct, eh? Okay, good. 1.0 Newton. So the sine theta, okay, the angle. Before you try this question, make sure you know what is the meaning of angle here. Define which angle. So the angle here given in the angle given in the formula here is between B and I. B and I. So look at the angle here. 30 degrees is between L and I. So we can use this angle substitute into the equation. Okay, so sine 30 is the correct angle. Okay, so you substitute the value of L. Next is the sine theta here. If you resolve the component of L here, so we get L cos theta and L sine theta. This is L. L means in the direction of I. Okay, L is in the direction of I. So if I in this direction, so when you resolve the component, you will get L cos theta and L sine theta. So if you use Pythagoras theorem, you will get back the length L. You will get back L. Okay, so that's what is meant by resolving the L. Okay, L cos theta to L sine theta. So L cos theta we don't use, we use L sine theta because L sine theta is perpendicular to B. Okay, L sine theta you see here is perpendicular to direction of B. So that's why we use 0.10 sine theta. Okay, so next we substitute B and L. Okay, B and L. So we get the answer 1.0 Newton. Okay, I hope you all understand why is sine theta is sine 30 degrees. Because we want the F, B and L perpendicular to each other. Okay, from the general expression for the using Fleming's left hand rule. Okay, so we've done this. Okay, so another one. The question said that find the magnitude of the magnetic force. The question just asked for the magnitude. What if the question asks what direction? Direction of force. Force is actually the physical quantity. Okay, vector quantity. Force is a vector quantity. So when you answer this type of question, especially in the essay question, you must write together with the direction. Okay, remember the question state here, find the magnitude only. But if the question asked in the essay question, you must write together with the direction. So if you answer like this, still incomplete because no direction given. So you use Fleming's left hand rule to determine the direction. Okay, so let's do this together. B this way, okay, and then I, if you convert it to the 3D diagram, okay, I upward. So the force is into the screen, okay. So can write here into the screen together with the magnitude. 1.0 Newton is the magnitude. Okay, direction is into the screen. Okay, so make sure when you ask the question like this, especially in the essay, if you write the magnitude, must also together write the direction. Okay, let's try the question now become harder and harder. Okay, so we go to the next question. Okay, question 4 here. So let's read the question first. A wire carrying a 10 ampere. Okay, this is a wire carrying a 10 ampere current has a length L equals to 0.20 meter. Okay, the length 0.20 meter in a magnetic field B. And the angle theta shown in the diagram here is 30 degrees. Okay, and the B is 50 Tesla. Look at the direction, is the dot, right? So be careful, the direction B is out of the screen given the magnitude is 50 Tesla. Okay, what is the magnitude of the magnetic force acting on the wire? Okay, so can you all calculate now? I hope they all memorized already the formula. Okay, now we come to question 4 already. So you must memorize in your mind the formula. So I just write down here, F equals to BIL sine theta. So what is your answer? What is the magnitude of the magnetic force? Anyone can answer? Okay, actually you can answer this very fast. In 1 second you can answer already. For those who really understand, 1 second can answer already. So why I say 1 second there? Anyone?
Okay, dah ada yang jawab, Madam.
So
50 Newton.
50 Newton. Okay, are you sure, Chen Kaki? 50 Newton. Any more answer?
Okay, another one answer. Gao Min Chai, 86.6 Newton.
86.6 Newton. You must be, I think you all students, you confused with the theta. I give the clue. So be careful where the theta is. Where the theta is. Theta given, is it the theta between B and I? I stroke L. Is it theta between B and L? So must be very, very careful. Okay, that's the first clue. The answer is 100 Newton. Okay, so where you go wrong? Check carefully. So the question might be tricky question like this. So you must be very careful where the theta given. Okay, theta given in the diagram. This dotted line here, between the dotted line. Whereas the B direction is out of the screen, given by the dot. So B is out of the screen. And the wire here lies like this, on the screen, lies on the screen. Okay, so therefore the theta between the I and the B actually 90 degrees. Can you see or not? Can you imagine or not? Okay, very hard to imagine actually, but you see the dot here, it's into the screen, whereas this one, the what you call this, the wire here lies on the screen, lies on the screen. The B is out of the screen, so it's still 90 degrees. Okay, still 90 degrees. I can show you the here how the sign is 90 degrees instead of 30 degrees. So actually what you see here is wire perpendicular to the magnetic field. Okay, so into the field, so current this way, right? This way current. Okay, current this way, and B is into out of the screen actually, out of the screen. So actually opposite direction is out of the screen. So actually wrong. This one wrong, the diagram here. So actually the force is this direction. Okay, it's okay. This one, we get the answer F, 100 Newton. Force not this way. Force is opposite way. Okay. If you cannot turn your hand like this, if you get the B, if you use the B like this, so that's mean the final answer of F will be opposite direction. So it's downward actually. Okay, downward, because B is out of the screen, not into. What I show here, the diagram here is into the screen. Okay, so make correction of the direction of force. Okay, then okay, before that, any question of this one? I hope you all can understand why it is 100. So I hope you all know where you go wrong just now. Okay. So those who get correct 100 Newton are very good. Okay. So as a conclusion, you must alert where the theta given is. Okay. Remember, theta, the angle is between B and L, stroke I. B and L. Okay, so we still got time, right? Okay, so we go to the next question. Okay, so the question, read together. Question, a current I passing through a uniform magnetic field B, okay, experience a force F, Okay, given here in diagram. So which of the following statements about F is not always true? Okay, which one? Choose one answer only. Which one is the correct one? Okay, which one is not always true? A, direction of F depends on the angle between I and B. Direction of F depends on the angle. And then strength. Okay, strength means magnitude of F. Okay, strength of F given by the magnitude of F depends on the value of the current. And then C, strength of F depends on the angle between I and B. And finally, direction F depends on the direction of current. This one is direction. Direction of F depends on direction of current. So which one is the answer? Anyone? Can write there in the chat box. Okay, any answer?
Okay, C lagi kaki. Dia bagi answer, given answer C.
C, okay. What about the rest of you? Anyone with different answer maybe, so that we can discuss? Don't
Okay,
afraid.
kau Micha, given answer B.
B, okay, we have B and we have C, so we can
B.
the correct. Any more answer? We have two different answers here. Which one is the correct one? So got any more answer or not? A, B, C, D. Always refer to the formula just now, how you really understand the F equals to BIL sine theta, and also Fleming's left-hand rule. Fleming's left-hand rule. Okay, the statement here said not always true. F not always true. No more. So B, and what about the other? Don't know the answer whether A, B, C, D. Which one? Okay, we discuss now. Okay, neither of you is correct. B, C is wrong. The answer is A. Okay, the answer is A. Direction of F depends on the angle between I and B. So this one not always true. Sometimes not true. It does not depends the angle between I and B. Okay. Because we always get the perpendicular, always convert it to the, means Fi and B must perpendicular to each other. Okay, let's say in this given, you see this, let's say you change the direction of I here. Okay, so the angle now becomes smaller, right? The angle now becomes smaller, right? But the F, direction of F still upward. Only the magnitude change. Okay, but the F still points upward. Can see or not? So it's not always true. Direction of F, not always true. Depends on I and B. So even you change the I here to smaller angle, so the F still points upward. You see, you use the Fleming's left-hand rule. Force still points upward because you resolve the component F and either B and I. Which one you resolve the component? You still get the perpendicular to the B field. Perpendicular to the force. Force is perpendicular to field and force also perpendicular to current. Okay, let's use another bigger angle. Okay, so if you use Fleming's left-hand rule, okay, it's still direction of F still point upwards, right? That's why the answer is A. Okay, not just now I forgot already who answer B and C. So it's wrong, B and C is correct. Okay, it's the magnitude depends, but direction, okay, not necessarily depends on the angle. Okay, because the question asks for not always true. Okay, so look at here. You change the direction of angle. You change the angle here. The F, your thumb still point upward. Okay, still point upward. So it doesn't matter. Understand? Okay. Okay, now what about the B and C? So the B and C, okay, B and C is Correct, because from the formula F equals to BIL sine theta. So F, what is meant of strength here? Strength is magnetic, means the magnitude. Okay, strength of F means the magnitude of F. So the magnitude of F is given by BIL sine theta. Okay, so it depends on the I here, depends on the value of current. So if you change the value of current, the F also change. If you increase the I, F also increases. Okay, same as C also. So C depends, okay, just wait just now, okay, same as C also. C, F depends on the angle between I and B. So this one angle, so if sine theta, you increase the sine theta, so F also increases. See, so B and C refer to the F, okay, magnitude, strength here. Whereas A wants direction, And finally the D. Okay, the direction of F depends on the direction of the current. Because you see the current, you change the current. Middle finger shows the current, right? So you change the direction of the current. What happened? So direction of force also change. Look at the thumb here. Okay, look at the thumb here. So D is not the correct answer. Direction of F depends. Depends is the correct answer. Sorry, direction of F depends on the current. Depends on direction of current here. Because you change direction of current, refer to the middle finger here. Okay, I hope this video can explain the D, why the D question is not the answer. The true answer lah. The question wants the not true answer, right? Okay. Okay, so I hope you all understand. Okay. The more understand, okay, how to use the F equals to BIL sine theta. Okay. So next, I hope we can manage to finish this question, question 6. Okay, I think got one more question. A straight length of copper wire 1.2 meter long with a mass of 48.0 gram has a current of 28 ampere flowing through it. Find the magnitude and direction of the minimum magnetic field B that is needed to suspend the wire. So that is to balance the gravitational force acting on it. So now the questions become harder and harder, and I think for 2 days we managed to answer 6 questions, discuss 6 questions, and for today's discussion this is the hardest question. Diagram not given. Okay, diagram not given. So you must draw. Sometimes diagram not given, so you must draw the diagram. Okay, so let's do this together. So I will give the similar question later after discussion here. Okay, so a straight wire. This is the B direction. So you assume the magnetic field direction or magnetic field strength, okay, direction is into the screen. You can draw out of the screen also. It's up to you because diagram not given. Okay, diagram not given. So you assume the B direction is into the screen. And then what else? We need a wire. So you draw a wire. So no need to draw the complete circuit. Just draw the wire and the current pass through it. You know as I. Okay, so the direction of current we don't know yet. We don't know yet. But the question said we want to balance the wire so that it's we can need so that it float here in the air. Okay, float in the air. So what does that mean? Float in the air. So that means the force, all the forces upward is equals the forces downward. Okay, so we need to determine the force first. Okay, before we determine the current. Okay, we use Fleming's left hand rule, but we need to use opposite way. Force first. We need to determine the forces first. So what are the forces act on the wire? And remember that the forces must balance upward. All the forces upward balanced by the forces downward. So what are the forces act on the wire? Anyone? Yeah, the forces act on the wire. Chukakit 0.014
Tesla.
Okay, so let's check the answer.
Upward.
Okay, so we have magnetic force and weight. Magnetic force and weight. Okay, so we have negative force, surely upward, because the weight downward, always downward, right? The weight. Okay, the weight downward. Okay, so F equals to force downward. So that balance, both of them balance, and the wire manage to float, okay, in the air. Okay, so we use this relationship. Okay, before that, current direction. The question didn't ask, but it might ask in the essay question. In the essay question, the direction of current. So we can determine direction. Yes.
Sorry, Madam Rosmaya, Gao Min Chai tanya, we can assume the angle is 90 degree, right?
Yes. Angle is 90 degrees. Mentioned in the diagram or not? It should mention in the diagram, 90 degrees. Okay? So not given here. Okay, good, it must be mentioned in the diagram here. Okay, so the force upward and the B into the screen here. And lastly, direction of current should be this way. Okay, this might ask in the essay question, direction of current. So not given, but it might ask in the question. So for direction of current should be this way. If you give opposite direction, so both F and weight downward, so it cannot it cannot float in the air. Okay, it cannot float in the air. Okay, so now this is extra information. Okay, we can get direction of current. Okay, the rest is the calculation part lah. Okay, let's check whether just now you give the answer same or not as the given answer here. So substitute the I and L value, and M is 0.048. Convert to kilogram. Okay, make sure you use all SI unit because Tesla is an SI unit. Ampere also already SI unit, here meter SI unit. So gram also must convert to SI unit. And finally, the G value, don't use 10, use 9.81, okay. And the answer is 14 times 10 to the power of negative 3 Tesla. Okay, correct. So just now who answered 0.014 Tesla? Okay, very good. Okay, congratulations. Okay. So, actually you can draw like this also, out, but the direction is opposite, opposite way. Okay, the answer is still the same, if you are asked to draw. Okay, so I think we have been discussed for 1 hour already. Okay, the rest of the question that I post in the description part, you can do, and maybe you can, we can discuss it later, in the next class maybe. Okay, that's all for today's discussion.
Okey, terima kasih diucapkan kepada Madam Rosmaya atas perkongsian ilmu yang sangat bermanfaat, mudah difahami dan sangat menarik. Alhamdulillah dah selesai kelas kita pada petang ini. Tahniah diucapkan kepada semua yang setia mengikuti kelas pada petang ini dari awal sehingga ke saat ini. Sebelum kita tamatkan sesi siaran langsung hari ini, mohon tutup ruangan chat dan klik butang subscribe dan aktifkan ikon loceng supaya anda tidak terlepas sesi kelas yang seterusnya. Sekiranya anda suka dengan apa yang dipelajari hari ini, sila klik like dan share kepada rakan-rakan di media sosial anda, FB serta Insta anda untuk sebarkan ilmu dan beroleh kebaikan di atas perkongsian tersebut. Sila type down di ruangan komen sebelum link CJ akan diberikan sebagai tanda terima kasih daripada cikgu kerana kehebatan kamu menyertai kelas tuisyen percuma pada hari ini. Okey, sebelum cikgu akhiri, cikgu akan bagi kod yang terakhir. So, kod yang terakhir untuk claim kredit kita adalah nombor 4. Okey, nombor 4. Okey, anda telah mendapat keempat-empat nombor kod untuk tebus mata kredit. Link diberikan di ruang komen dan pastikan anda mempunyai ID Junior e-Didik untuk menebus mata kredit berkenaan. Link sijil boleh didapatkan pada bahagian chat. Kod akses adalah #KelasAYU e-Didik, #KelasAYU e-Didik. Sila ambil perhatian, link tersebut akan tamat tempoh setengah jam selepas live ini. Pastikan anda guna email e-Didik sahaja ya. Okey, sekali lagi saya ucapkan ribuan terima kasih kepada Madam Rosmaya dengan kelas petang yang amat menarik ini. Tahniah juga diucapkan kepada semua yang setia bersama kelas pada petang ini dari awal sehingga ke saat ini. Okey, kelas seterusnya untuk tuisyen fizik PRAYU adalah pada waktu yang sama pada minggu hadapan iaitu hari Ahad pada pukul 5 petang. Anda semua dijemput untuk ke portal www.academyyoutuber.com untuk dapatkan jadual tuition dan info terkini. Bantu cikgu untuk sebarkan kelas tuition percuma ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Usaha ini adalah hasil gabungan guru-guru seluruh Malaysia untuk semua para pelajar seluruh Malaysia, terutamanya dalam menghadapi saat genting melawan pandemik COVID-19 sekarang ya. Okey, semoga kita mendapat manfaat daripada kelas yang dijalankan. Ingat, hashtag bermula percuma, selamanya percuma. InsyaAllah. Terima kasih kepada semua. Segala yang baik itu datangnya daripada Allah. Jika terdapat sebarang kekurangan dan kelemahan itu adalah daripada kami. Cikgu akhiri kelas pada petang ini dengan serangkap pantun ya. Petang minggu, petang bertuah, masa kosongkan minda, istirahat diri. Kelas tuition online percuma berakhir sudah. Di lain siaran kita berjumpa lagi. Assalamualaikum dan selamat petang. Bye-bye.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.